To prove lines parallel in coordinate geometry, we use formulas. Now in coordinate geometry, the formula that we would use would be the slope formula. And we'd want to show that the two lines that we're trying to prove parallel have equal slopes. In plane geometry, in order to prove that two lines are parallel, we need to write a proof. And to write that proof, we need properties, definitions, postulates, and theorems. So what we need to do is we need to find some postulates and theorems that will prove lines parallel. Well, we have some postulates that involve parallel lines. All of these theorems and postulates start with lines being parallel and then conclude about the angles. Well, if we use the idea of a converse, we can flip all of these postulates and theorems around and conclude that we have parallel lines. So in order to prove lines parallel in plane geometry, we need to find angles that are congruent or angles that are supplementary. If we have that, then we can conclude our lines are parallel. So the corresponding angles converse says this: if we can prove that our corresponding angles are congruent, then we can conclude that we have parallel lines, proving we have parallel lines. If we can show that our alternate interior angles are congruent, then we can conclude that our lines are parallel, proving our lines are parallel. If we can show that our alternate exterior angles are congruent, then we can conclude that we have parallel lines. If we can show that our consecutive interior angles are supplementary, then we can conclude that our lines are parallel. So these are the four ways that we're going to prove lines parallel in plane geometry. Let's take a look at an example that involves this. In this proof, we need to prove that line 1 and line 2 are parallel to each other. And we're given that M1 and M2 are parallel, and angle 2 and angle 3 are congruent to each other. So the idea is we need to figure out what's going to prove line 1 and line 2 parallel. So let's look at line 1 and line 2. If we look at line 1 and line 2, we have two transversals, M1 and M2. And if we look at the transversal M2, there's only one angle that's labeled angle 3. If we look at transversal M1, there's actually two angles labeled, angle 1 and angle 2. And angle 1 and angle 2 are actually alternate exterior angles. So if we could show that angle 1 is congruent to angle 2, then by the alternate exterior angles converse, our lines will be parallel. So ultimately, our goal in this proof is to prove that angle 1 is congruent to angle 2. If we can prove that, then we can conclude that our lines are parallel. The key is we need to get this to be true, not because they're alternate exterior angles, but we need this to be true some other way, and then conclude that our lines are parallel. If we just say that these are parallel because of alternate exterior angles, that would imply that our lines are already parallel. They're not yet. That's what we're trying to prove. Don't jump to the conclusion that these are congruent because they're alternate exterior angles. So let's look at our givens. M1 is parallel to M2. Well, parallel lines always give me congruent angles or supplementary angles. So I'm going to look at M1 and M2 being parallel. And I'm going to look at the two transversals, L2 and L1. Well, L2 only has one angle labeled, and that's angle 2. But if I look at transversal L1, I have two labeled angles, 1 and 3. And if you look, 1 and 3 are corresponding. And if our lines are parallel, which they are, that's given to me, my corresponding angles will be congruent. So because line M1 is parallel to M2, angle 1 and angle 3 will be parallel. Now I also know that 2 and 3 are congruent. That's given to me. So if 1 is congruent to 3 and 2 is congruent to 3, we know that 1 and 2 have to be congruent. We could substitute in angle 2 for angle 3. So we could conclude this is true, not because they're alternate exterior angles, but by substitution or the transitive property, and then conclude my lines are parallel. So the idea is figure out which angles need to be proved congruent or supplementary to prove the lines parallel, then use the givens to get there. So let's write our proof. Our first statement is our first given. And parallel lines always give me angles. So I can conclude that 1 and 3 are congruent because they're corresponding angles between parallel lines. So by the corresponding angles postulate, they are congruent. Now I could also write it this way. Parallel lines give me corresponding angles that are congruent. So I don't need to write out the corresponding angles postulate. I can say this. Parallel lines give me corresponding angles congruent. Step 3. I'm going to hop to my other given. Angle 2 is congruent to angle 3. Now if I look carefully, 1 and 3 are congruent, 2 and 3 are congruent. That means that I can take this statement and plug it in right here and conclude that angle 1 is congruent to angle 2. Now realize the reason this is true is not because they're alternate exterior. The reason this statement is true is because I'm substituting steps 3 into 2. I could also call this the transitive property. Now, since 1 and 2 are congruent, not because they're alternate exterior angles, but because they're both congruent to the same angle, I can now conclude that L1 is parallel to L2. Why? Because 1 and 2 are alternate exterior angles, and the alternate exterior angles converse, the converse says that if my alternate exterior angles are congruent, then my lines are parallel. I could also write it like this. Because my alternate exterior angles are congruent, I can conclude that I have parallel lines. Realize that 2 and 1 are congruent. Some other way proving that my lines are parallel. Don't rely on the fact that they're alternate exterior angles to prove that they're congruent until the lines are parallel.